Alright, guys, let's start a session. The line on the Earth's surface joining the points where the Earth's magnetic field is horizontal is called. Yes, Nishit, right answer. Yes, Kritika, right answer. Yes, Sumedha, right answer. A homogeneous electric field E and uniform magnetic field B are pointing in the same direction. A proton is projected with its velocity parallel to E. What will happen to its speed and direction? Yes, Kritika, right answer. No, Sumedha, wrong answer. Shall I tell the solution? All right. The magnetic field and electric field both are pointing in the same direction. A proton is projected with a velocity parallel to this, which is positive proton. So we know that current does not get affected with parallel magnetic field. So magnetic field will not have any effect on this, but this will get accelerated by electric field. So it will go on moving in the same direction with increasing velocity. Three identical bar magnets, each of magnetic moment m, are placed in form of an equilateral triangle with north pole of one touching the south pole of the other. The net magnetic moment is. Yes, Kritika, right answer. No, it's a wrong answer. All right. Okay. We know that magnetic moment is a vector quantity, and so if you take the resultant of all these three, as this is an equilateral triangle, so they will get cancelled out. So the answer will be zero. The magnetic induction field at the center C of this arrangement is, and this wire is till infinity. No, Sumedha, wrong answer. Yes, Nishya, right answer. Yes, Kritika, right answer. Alright, the magnetic field at the center is going to be because of this semicircular loop as well as this infinitely long wire. So because of this semicircular loop, the field will be mu naught I by 4r, and by this infinite length wire will be mu naught I upon 4 pi r, because this is at its end, so it will be upon 4 pi r. Otherwise, at other distance, it would have been 2 pi r. So adding both of them, we'll get A as the answer. A circular coil A has radius this and current flowing is this. There is another circular coil B and radius 2r with current 2I. Then the ratio of their fields at the center is. Yes, Kritika, right answer. No, Sumit, wrong answer. Yes, Nishya, right answer. No, Sumit, wrong answer. All right. The magnetic field at the center of a circular coil is given by mu naught I by 2r. So the radius is increased by 2 times and current is also increased by 2 times. So it will still remain the same. So the ratio will be 1:1. Earth's magnetic induction at a certain point is this. The field is to be annulled by the magnetic induction at the center of a circular conducting loop with the given radius. What is the required current? They want to produce a magnetic field equal to this value at the center. Yes, Kritika, right answer. No, Nischay, wrong answer. Yes, Sumit, the right answer. Nischay, I think you forgot to convert centimeters to meters. Yes, that's the right answer. We'll simply equate 7 into 10 to the power minus 5 to mu naught I by 2r. So I will be 7 into 10 to the power minus 5 into 2 into 5 into 10 to the power minus 2 upon mu naught. Mu naught is 4 pi into 10 to the power minus 7. So if you calculate this value, 10 to the power minus 7 gets cancelled, and this will give the answer 5.6 amperes. C is the right answer. A current I is flowing in an equilateral triangle of side A. The magnetic field at the centroid will be. Yes, Kritika, right answer. No, Sumit, the wrong answer. Shall we proceed with the solution? All right. All right, let's proceed with the solution. The magnetic field at the centroid will be because of all the three wires, and all of them will be adding the field. So for one wire, it will be mu naught I by 4 pi d into sine alpha plus sine beta. So alpha and beta are 60 degrees multiplied by 3. This will give me 9 mu naught I by 2 pi a as the answer. This is an equilateral triangle, right? So the angle which will be formed between these three is 120. So alpha and beta in this formula are the angle made with the perpendicular bisector towards the ends. Alright, so that is why it is 60 and 60. Yes, Nishya, right answer. Yes, Kritika, right answer. Alright. Work done in turning the magnet from any one position to another position is given by minus mb into cos theta 2 minus cos theta 1. Alright, so the work done for doing this will be minus 2.5 multiplied by 0.2, and cos theta 2 is in anti-parallel position, that is 180. So cos 180 is minus 1, minus parallel is 0, so cos 0 is 1. So this is minus 2.5 into 0.2 into minus 2. This will be 5 twos are 0.5 twos are 1. This will be 1 joules. Two long parallel wires P and Q are held perpendicular to the plane of the paper at a separation of 5 meters. P and Q carry currents this and this respectively in the same direction. Then the magnetic field at a point midway P and Q is. Yes, Kritika, right answer. Shall we proceed with the solution? Alright. The two long wires are perpendicular to the plane of parallel to the plane of paper and parallel to each other. Currents are flowing in the same direction. with 2.5 and 5. So magnetic field because of the first one will be in this direction, for the second will be in this direction. So they will get in opposite directions, so we'll have to find a difference between them. So difference will be mu naught I1 upon 2 pi d minus mu naught I2 upon 2 pi d, that is mu naught upon 2 pi, and d is the midpoint, which is 2.5, and difference in currents is 2.5. So my answer will be mu naught upon 2 pi. The wire loop formed by joining two semicircular sections of radii R1 and R2 carries a current I as shown. The magnitude of magnetic field at the center C is. Yes, Kritika, right answer. Yes, Nishya, right answer. Alright, as the currents are in opposite directions, so the magnetic field at the center will be in opposite directions, so they will get subtracted. So magnetic field by a semicircular loop is given by mu naught I by 4r. So taking their differences for R1 and R2, we'll get D as the right answer. A length of wire carries a steady current. It is bent first to form a circular coil of one turn, then it is bent more sharply to give a double loop of smaller radius. Then the magnetic field at the center is what compared to the first case. Yes, Kritika, right answer. No, Nischay, wrong answer. Alright, let's proceed with the solution. No, Sumit, the wrong answer. The magnetic field is given by mu naught n I by 2r. So the first case it is mu naught I by 2r, and for the second case it is mu naught 2I by. Now the perimeter has been distributed to two turns, so the radius will become half, so it will become r by 2. So we can clearly see that b2 has become 4 times of b1, so the answer will be C. Alright guys, that's all for today. Thank you for joining. Good night.